Earlier, we have seen what a node is and how it can be created and what is the structure of that node and what is a self-referential structure. In today's session, we can discuss how to create a linked list using these nodes or linking these nodes and what all operations are available over this linked list. So when we have a list is formed by connecting every node available. Once a list is being created, we can extend the list by addition of new nodes. In such a case, we can add a node at 3 locations. They are at the beginning of the list, at the end of the list, and between these 2 points, that is at a given position. It will not be at the beginning or it will not be at the end. So at these 3 locations, we can add a node, a new node to a linked list. So that if the number of nodes in the current list, linked list, is x, when we add one more node to it, it becomes x plus 1. So we'll be seeing how to add a node to a linked list. This is known as node insertion. Adding a node to a linked list is called as node insertion. Suppose this is the list that we have already created. So this list is having 4 nodes and the last node will be pointing to null. Every other nodes are pointing to its succeeding nodes. This is the first node which points to the second node. This node points to the third node and the third is pointing to the fourth node and the fourth is not pointing to any other nodes. It is pointing to a null value, which is an invalid address. We have also seen if we want to get into the list, we should have the address of first node. Usually it is referred to as the head pointer. So these arrow marks are all pointers. They are used for pointing to nodes, pointing to locations where memory locations where a node can reside. So head is a pointer. Here we will be having a pointer which points to the second node. This is a pointer, means an address which is the address of the very next node, and here also we will be having an address which is the address of this last node. Last node is represented by a null value in its address location. We have also seen that a node is having minimum of 2 fields. One is used for storing information and the other is used for storing address of a node. This will be the structure for all other nodes in the list. So keep this in mind that we have a list which is pointed out by a head pointer which is having the address of first node. So this will be the case with every linked list, that is the head or start. We'll be using we can use any name instead of this head. It is user dependent. It is used for getting into the list. Therefore, it will be having the address of first node. And the list will be terminated by a null address. So this is a list that is present now, and we are inserting a node into this list. First, we'll be looking at insertion at the beginning of the list. Suppose this is the node we are creating. We have studied that when we are creating a node, there are several steps. We have to declare the structure of the node. As per this figure, that node is having two fields. One is the data field and another is the next field. The next step is to allocate space for this node. You have to allocate space for the node by using malloc function. Once the space is allocated, we can store values into it, and the values should be a data value at the first field, and here we should have a null field. Once we assign these two values, we can have, or we consider this as an independent node. This node has to be inserted into this list. Now this list is having 4 nodes now. By the addition of this node, we will be having 5 nodes in the list. Where to add this node? We have to add this at the beginning of the list. When we consider this as the linked list, this is the beginning and this is the end. The head will be always pointing to the beginning node. Once this is added to this location at the beginning, this becomes the second node, this the third, the fourth and the last node. So when this becomes the first node, what is the difference that happens in the list? Then head should point to this node. This null should point to this node. Is that right? When this node is added to the beginning of this list, this head should point to this. Why? Because after addition, this node becomes the first node. Head always points to the first node. So head should have address of this node. In figure, we will be showing like this, an arrow to this node pointing to this, and this null will be pointing to this node. So we are assuming a new node. The name of this node is new node. Name of this node is new node, new underscore node, with data field having the value 15. This has to be inserted at front, and address part of new node should point to the head node, because this is the head node right now, and this address part should point to this head node, and this head should point to this new node. Okay, so after the insertion of this node, this becomes the head node. So this has to be kept in mind while we are going into the algorithm of insertion process. So this will be the change in figure. This head will be pointing to this location. We have also seen that when head is a pointer, it cannot point to 2 nodes at a time. So when we use this as the link, this will get cancelled. This link will not be available. So this will be the structure of the list. Head will be pointing to this node, and the address field of this node will be pointing to the first node. So this will be the change. After this change, we will be having 5 nodes with this as our new node as the head node. Okay. Let us see the structure and function declaration with regard to this process. And these are all simple statements. We are including some header files here. And we are creating the node. We have seen this in the last class. Node is the structure tag name. And there are 2 fields. It is arbitrary to have any number of fields. We can use any number of fields here. For simplicity, we are considering only 2 fields. One of them should be addressed to the next node, because self-referential is the definition for linked list, and there should be at least one information field. For that, we are naming it as data, and the link or self-referencing as next. So this will be the figurative model of this structure. It is having 2 fields. One is data, an integer value here. Another one is next, a pointer value here. If there is a star here, this can be treated as a pointer variable. We can store only memory location address here. And we also declared a pointer variable to a node, which is declared as head. We have defined head as a pointer variable. This will be having the address of first node of the linked list. It is also called as the header node. Then we will be using some functions. These are the function prototypes. Create list with an argument integer value. Insert at beginning is the name of the function with an integer value again. Then a display list function will be defined later part of our slide. And this is the main function. From this we will be calling the other functions we have just prototyped above. Int main is the header of the main function. We are declaring 2 variables. Both of them are integer. 2 integer variables are being declared, n and data. Let us see what n means and data means. This is a prompting string. Enter the total number of nodes. That means when we are adding a node to a list at the beginning, we should have 2 things. One is the new node to be added, and the other already existing list. So this n is for creating that list. In our previous example, in the example here, we are having 4 nodes in the already created list. So we should pass this value of 4 to that n. Okay. So we will be entering n as the total number of nodes in the list, and we will be using a function create list with 4 as the value, so that 4 nodes are linked together to form a list. To this list only we are adding a new node at the front of the list. So we can pass any value here according to our example just shown just a minute before. We are having 4 nodes in the already created list. So we are passing 4 here. We are passing 4 as n to this function create list. Then we are displaying the list. We will be seeing that in a later slide. Then we are entering data to insert at beginning of the list. We are creating a new node, and for that just we have seen that we have to add 15 into the list. So we are scanning the data as 15. Then we are calling a function to insert that node at the beginning, and we'll be passing 15 to that function. All these things you might be familiar with, because how a function is being used, how arguments are passed to the function, they should be clear with you to understand these topics. We have discussed this in detail in the previous semester. So we are calling a function insert at beginning with the data 15 here. So 15 is being passed to this function. Then again we are displaying the list by calling display list, and these are the ending statements in the main function. Now this is the create list function. We are creating or declaring two pointers, node pointers, new node and temp. So this makes 3 pointers now. Head is one pointer. We have already declared that along with the structure, node structure we have defined. The new node is another pointer. Temp is another pointer. By using these 3 pointers, we can point to any node having this structure, data and next structure. Okay. So we have defined 2 node pointers. We are declaring 2 integer values. One is data and the other is I. We will see what I means. Then we are requesting for a memory space to store a node of this type, and the function used here is malloc. Malloc means requesting for memory space. How much of memory space? It is the size of node. That much of memory space should be made available, and its address, starting address, should be stored in head, so that head becomes the pointer to that space. So malloc returns a void pointer. We have to convert it into node pointer. So this is the syntax for using malloc function. And head, once it is successfully done, head will be having a valid address. If this function returns a null value, we say that this request is being turned down and head is having a null value, so that we cannot proceed. Memory allocation is not made available, so we may not be able to proceed with the procedure. So head should not have this null value. If it is not the null value, we will be coming into this else part. If it is null value, we will be proceeding with this part. So we should hope that this is not a null value. This function has already returned a valid address for this head, and we are proceeding with these statements in the else part.